Hello, everyone, and welcome to today's webinar. My name is Rhonda Seelinger, and I'm the Customer Engagement and Event Manager for iClicker. And we want to thank you so much for joining us today. We know it's a busy time of year, and we really appreciate your time. We are going to get started with the presentation momentarily, but I do have a couple of quick reminders. The first is I just want to remind everyone that you're automatically muted, and we do that just to help keep out background noise as there are a good number of people on the line. We do want to hear from you, so please use either the chat feature or the Q&A feature to communicate with us. I will be monitoring those throughout the presentation, and we do have some time set aside for Q&A as well. So you don't have to wait to type in a question or a comment, but we will do our best to get to everyone's feedback or questions throughout the broadcast. We are recording the webinar, and we will share a link within a day or two, and so be on the lookout for that, and you're free to share that with a colleague if you think they might be interested. We would appreciate that. And with those things covered, I am very pleased to introduce our guest speaker, Dr. Raj Chowdhury, who is the Executive Director of the Innovation and Learning Center at the University of South Alabama. Dr. Chowdhury is an experienced instructor and has given numerous presentations and workshops both domestically as well as internationally on active learning techniques in the classroom. So we are very pleased to have him. And Dr. Chowdhury, I'll pass it on to you now. Thank you.
Great, thank you very much, Rhonda, and good afternoon or good day to you, those of you who've joined the webinar. It's about the end of the semester here at South Alabama, and hoping most of you are having a good wrap-up to your fall semesters as well. So what I wanted to do today is really share some lessons that have driven my own past instruction in the classroom, and the topic of sort of faculty development workshops that I do nowadays related to thinking about active learning classrooms, and how, in fact, the lessons from the learning sciences, which is a field that's only about 2 decades old, have really informed much of the work that I've been doing over the last almost 2 decades of myself. So this is an adaptation of a workshop that I typically do in person with people. So there are some times where we have interactive moments. However, since the sort of logistics overhead of getting everybody on clickers was a little bit difficult in the short time that we have, I'd like you to do some thought experiments, and I'll, as we go through some of the question types that we're going to deal with today. So one of the things I always do in the beginning of a workshop is have a question like this up, and I typically do faculty workshops, and this is a question that in the K-12 world is known as a bell ringer. And I do something similar for my students. I used to teach physics when I was teaching full-time. And the idea is that just to set a expectation that, in fact, in this class or in this session that we're going to have, in the instructional session that we're going to have, that thinking and then doing something about the thinking, sharing your commentary about your thinking about a particular topic is going to be part of the engagement. So this really sets a tone early on that there's going to be some activity within this particular lesson. It's always good in any instructional setting to have some goals. So one of my goals is to learn a little bit about some of the application of learning sciences to create active engagement, and some of my inspiration in this work over the last several years. And then that hopefully that as participants you'll leave with some ideas for implementing active learning in your own classes. There is this picture. So here's our first thought experiment. This picture by Laurentius from about 1600s actually shows King Henry of Germany, who was, I think, a 14th century monarch, actually teaching. He was, in fact, a teacher and giving a lecture. And this has lately been making the rounds of many people doing these types of talks. But you look at some of the features in here, and there are some features which are very similar to today's classroom, and some that probably have evolved a little bit. But I'm sure all of us have the people talking in the back, the people sleeping, and then the front row of students who seem very attentive and actually brought their books, which is always an interesting aspect of any given class. Okay, so one of the interesting aspects of thinking about, what do students do when they're there? Do they just sit there? So my postdoc advisor Dean Zollman received the American Association of Physics Teachers Millikan Prize back in '94. And this really was the title of his talk, because he was one of the early proponents of active learning within physics classrooms, and thinking about, what are the processes that we'd like students to engage in terms of cognitive processes, possibly as kinesthetic processes as well. But what are those processes, and how much of those processes can actually be accomplished if you have a purely lecture setting versus a different type of active learning setting. And so this was one of the areas where I started to learn to think about how does one in fact create a classroom where there's more than just sort of sitting and listening and taking notes going on. So many of you have heard about things like, the 10 to 15 minute attention span. Donald Bly's book, this is the 2000 sort of US edition, it's called What's the Use of Lectures, had this really interesting sort of graph in it. So let me just show on the left-hand side, you have sort of beats per minute. So this is a physiological kind of heart rate information. And then you'll notice that the lecture's going on for about, the whole sort of 60+ minute period here. And then you'll notice the drop in heart rate at happening about halfway through the 0 to 25. So about halfway, that's that 12-minute mark, so to speak. There was a drop in heart rate. And this, of course, some people correlate that with a possible then drop in attention as well, because that's definitely arousal information. And then there's an intervention by a student later on, heart rate picks up again. And then during discussion, the discussion phase of this particular setting, you'll notice again, it starts out up in about 87 or so, then about 10, 15 minutes in, even with the discussion activities going on, there's a decay in terms of student heart rates, once again, as an indirect indicator of student engagement. So, so this is some of the setup. And what I'd like you to do now, and I'm going to be quiet for exactly 30 seconds, what's your webinar goal? So maybe you're an iClicker user, maybe you're interested in this topic of active learning. What would you like to get out of it? And so based on this intro I've given so far, take 30 seconds and write that down. Okay, so hopefully that will sort of give you a little bit of an orientation to think about what you hope to gain. I like to tell stories. This was a story, the Fish's Fish story, some of you may know of Leo Leone, the children's book author. This is actually a story that was both cited in one of the most fundamental works in the learning sciences, and also has been an inspiration to me in terms of my work. So, and remember, I'm a physicist by training, and so I don't know very much about tadpoles or fish or ponds or plants, but nevertheless, here's sort of my version of this quick story to share with you today. There's a fish and there's a tadpole, and the tadpole kind of looks like a fish. They're friends. You can see they look pretty happy. They play in a pond and do whatever fish and tadpoles do normally in ponds. But then one day there's cause for concern because the tadpole sort of transforms into a frog. He first grows front legs, then he grows back legs. And, you know, this is not something that happened to the fish because the fish just kind of became a bigger fish. And so, you know, they're arguing about this and they don't quite know what to do with it. There's nothing within their current framework of how the world works to really explain this kind of activity. I guess they were abandoned by their parents, so there weren't any parents there to teach them about the way the world works. So they have to sort of take it on faith. So they say frog is frog and fish is fish, and that's that. Not much more that we can really do, but we observe this transformation, but we don't know what to do with it. So the frog, of course, leaves the pond and is gone for a while. And then he comes back and he tells his friend, look, I've seen these wonderful things out there. The world is a great place. And there are these things called birds. And they have feathers and they have wings and they fly. And the fish is imagining what a bird might look like. Then the frog says, well, I've seen these things called cows. Cows, they have black and white markings, they chew cud, they have horns, and the fish is imagining, what does a cow look like? And then finally describing people. People, they walk on two legs, they wear clothes, and by this time you could probably visualize yourself exactly what the fish is thinking in terms of what people look like, right? So I'm going to digress from the story a little bit. Imagine the fish took a test. And this was the question on the test, right? Which of the following best describes a cow? Now the fish, if the fish, like your students, paid attention, and in fact listened carefully, they would answer, C, a cow, black and white markings, horns, chews cud, etc. So the question I always pose to teachers is that, well, I mean, are you happy with that particular answer, right? Are you happy with the picture that students might be building from your teaching? And this is the time when we have to think about the eternal. I got to cover all this material. So is coverage more important, or is in fact the way the students assimilate that information more important? And so this is where words like formative assessment come up, and in fact where technology can really give us some interesting ways of starting to think about what does the view inside my students' mind look like, right? And how much can I learn about that, and how they're processing this information that I'm passing on to them. So just to finish the story, because the story is really about the fish, because the fish then becomes curious about life on land and actually jumps to the shore, right? So he wants to experience all this stuff for himself, but then of course he couldn't breathe. And then luckily his friend came by and put him back in the water. And he says, you will die on land, fish is fish, and you must stay in the water. And this brings up this other interesting question, is that sometimes there are things that we want to experience firsthand, but we cannot because of whatever physical limitations. And so there's actually another role for technology here to really help us think about, what if we want to see what the surface of Mars looks like, or what do you want to see what inside a blood vessel looks like? That's where technology can play another role in really helping us get to those types of environments. So the work that I mentioned earlier is How People Learn. So the expanded edition published by the NRC came out in 2000, and they actually cite the Fish is Fish story within that book. And I was fortunate enough to hear a talk by John Bransford, one of the principal authors of this report, talking about the story, which really got me thinking. That was back in 1999, right before the report was coming out. And Bransford was also a big, huge early user of clickers. So you can actually read the book for free on the web. If you just look for the NRC, How People Learn, chapter by chapter, you can read the entire book. It's got some really great lessons. More recently, though, just a couple of days ago, James Lang, who's pretty famous for some other books like Small Teaching, he wrote a nice little piece in the Chronicle of Higher Education, so I'd encourage you to go and look this one up, called Playing with Technology. And he teaches English. And within the teaching of English, he really talks about ways in which he's used peer instruction and polling and how they've changed his teaching. So I'd highly recommend that one as well. So to get to kind of the technology side of things, why clickers, right? So there's all types of things that we as faculty are concerned about in terms of our students' learning. What's their prior knowledge, right? What kind of preconceptions might they have? What kind of misconceptions might they develop based on their interaction with the material? Sometimes it's about opinions, understanding, right? Do I get a sense of what their confusion level is? And then, of course, other things like how satisfied are they with certain aspects of the course? So I want to talk a little bit about engaging students. And remember, once again, this is something I do in faculty workshops. And so faculty, of course, come from various different disciplines. So sometimes I'll put a question up like this one, which I got from Doug Duncan's work. Duncan has a nice book on writing effective clicker questions. And I'll give you a couple of seconds to read this. And then after people have answered this, what I'll typically do is, of course, I will then have them turn to their neighbor and try to convince their neighbor to change their answer to yours. Right, notice the language there. So really try to convince your neighbor, and then we vote again. And one of the interesting things to look at always is how much quicker the second time through the votes come in. And so if you run the clicker on the count up mode, these votes after the discussion sometimes come in pretty quickly, right? So this one, of course, turns out not to be much about this nonsensical sciencey words, but in fact, English professors typically do very well with it because it's really about sort of doing semantic analysis of the word. And if you look on the third line, then bractor it to quasel traxylene. So the correct answer, if some of you are curious, how is traxylene quaselled? Well, it's quaselled via bractoration. But it's a good example, and it's a good reminder to faculty sometimes, is that students, when they come into our courses, right, courses in which we are experts and have been studying for dozens, decades possibly in certain discipline, that sometimes we put up questions which look like this to them, right, essentially gobbledygook. And so how can we use technology to help our students learn and get down to the type of learning behaviors that we really would want them to exhibit? So the process that we just kind of did the thought exercise on is, of course, called peer instruction. And peer instruction was kind of made famous in a book by that name, written by Eric Mazur, who's a physicist from Harvard. And physicists were some of the first group in higher education to realize that our students were not understanding what we thought we were teaching them. And so, which is why many of us have been really involved in this kind of process for a long time. And so here's a quick flowchart of peer instruction. Right, the ideal question is a question in which 30 to 70% of the students get it correct, because then there's a really good chance that two students sitting next to each other might actually have different answers, and that, of course, gives you that opportunity to have a discussion, and then the repolling can really be revealing. I like clickers because they provide feedback to the instructor about students' understanding, right? So here might be a particular graph, but at the same time, if you want to share this with your students, then it's a metacognitive moment, because you can actually then, students themselves can see, even though they anonymously answered the question, they can see how they stand with respect to the rest of the class. Right? So there, of course, has been a ton of data and a lot of studies related to the use of clickers in different settings. I like this one that I'm going to share with you from CBE Life Science Education from almost 10 years ago now, because it was done with very, very large classes, teaching intrabiology at the University of Washington. So this is Scott Freeman's group. And so here's a 2003 and 2005 comparison. Right, so this is students 2003, that's before they introduced clickers, right? And so the student point distribution for the overall course grade. And you notice the shift to this much higher higher scores in terms of students' performance. And so you might ask, what happened to 2004? Well, 2004, they were sort of really figuring out how best to use clickers with this large number of students. If you think back to those days, those were infrared clickers, so the logistics was definitely a lot harder. But nevertheless, they made it work. And it's sort of a very nice little demonstration of how you can actually demonstrate achievement shifts with students. So the other idea that Mazur introduced was the idea of concept tests. And a concept test is really a test, it's a conceptual test for use in clicker questions or any kind of questions, but works very nicely with clicker questions. And it's usually something where there's a small change. So a system either changes one way or the other, or it stays the same. And so it's a nice, easy kind of granularity in terms of what you're probing in terms of your students' understanding. So here is an example of one that I sometimes ask, relates to musical instrument. So if you hit the pegs downward all the way around on the tabla, and of course if you actually have one, so I typically use when I'm teaching, I'll actually do a demonstration in class with this, what would happen, right? And so the whole idea is you have a system of some kind, you perturb the system, right? Based on the perturbation of the system, would the system react by increase, decrease, or staying the same, right? So if we have big tax cuts, would that in terms of unemployment, would unemployment increase, decrease, or stay the same as a result of big tax cuts, right? That's the kind of a question you could use in a very different kind of setting. So sometimes, of course, the question itself is interesting, but sometimes you want to put it in terms of where you're asking possibly a sensitive issue, but in terms of the famous, my friend, I have a friend who has such and such problem, which is really your own problem. And so I did a workshop recently in northern India, and so the tabla happens to be a northern Indian instrument. So rather than get into the sensitive area of possibly faculty in northern India not knowing about this musical instrument, I posed it this way, right? So asking sort of the meta question, here's this question, how many people do you think in southern India got this right? And it just so happens a cultural thing here is that southern India has different musical instruments for their classical music than northern India. So this was sort of a fun way to present it, but it's once again a question type that you can do if you want to ask about some particular sensitive topic. Probing misconceptions. My background, once again, is in the sciences. So, of course, there's lots of sort of well-documented misconceptions that people have. There was a really nice set of videos put out in the 90s, and the Annenberg people actually put this one out in 97, which goes to some very fundamental aspect of nature. Where does most of the mass of the tree comes from as the tree grows, right? And this is counterintuitive because you have to think about a big log of wood. It's got all this mass, and the place that most of that mass comes from, right, the dried weight, is of course the air, right? Because the carbon dioxide from the air is where this stuff comes from. So that's just this very counterintuitive thing. We see air as essentially, we don't think about the mass of air, we don't think about the constituents of air when we're breathing it, but of course that CO2 is in there, and that's what allows us to capture the carbon to be able to have trees grow. Right? So this is an example of a way in which a clicker question can be a great way to actually capture student understanding about this. And this particular question is well documented in the science education literature, something that students have a lot of difficulty with. To use another term from Bloom's taxonomy, application. So I'm going to give you an example, once again, from the sciences, but it's also an example where I really wanted to think about how can we help faculty do quick and dirty creation of good clicker questions, right? And so most of you might have publishers who have publisher materials, and so sometimes you can take publisher materials, sort of slides that they've given you, just the prepackaged lectures to go along with the textbook, and make really interesting clicker questions out of them. So here is one that I guess originally designed in 2014 when the World Cup soccer was going on in Brazil. And you can see at the bottom it comes from a Freeman book, The Economy of Nature, right? And what I did, I took this into PowerPoint and I did a very, very quick and dirty, right, job in terms of editing this. As you can see, it looks pretty crappy, but it gets the point across for this particular question, which is about students reading graphs. The nice thing about something like this, because there's a bunch of different information on it, is that you can then use it again, right? So if you put some time and effort into creating this diagram, why not have a different question? So the last one was about Manaus, which is a Brazilian rainforest, so it's a hot and rainy kind of place, right? And then the other question I ask here is that about the frozen tundra of Siberia, and once again, the students have to really kind of read the graph and just pick a letter in this particular case, since it goes up through J. If you had an iClicker, you'd be using the alphanumeric display to have them enter the letter J would be the correct one here. And here I'm going to just show you what the original looks like, right? So this is what the original looked like. So you can see the kind of work that I did, made it black and white, and then just did some cheap Photoshop editing on it to get it to where I wanted to give me 2 questions. So that's like double the bang for the money. All right, so one of the people who really impressed me with his design of clicker questions when the first alphanumeric stuff came out is Richard Morrison, who used to teach organic chemistry at Georgia. And so I'll give you run through a couple of quick examples here. I don't know if we have any organic chemists on the line. You'll appreciate this. So here is a kind of a Diels-Alder reaction pair question, which he knows is difficult for students. And so the point is, student has to pick one from the left-hand box and one from the right-hand box, right, to end up with this particular product at the end. And so that the way that students would enter is that they would enter essentially a 2-digit code as their response. In this particular case, it turns out to be 27. 27 is the right combination of reactants to give you that particular product. But what, because Dr. Morrison had collected a lot of data over the years, he knew that most likely when students would enter these incorrect answers, right, these would be recorded, of course, but when students entered these incorrect answers, they most likely had the misconceptions or some difficulty understanding with these particular subtopics. And so if anybody came to see him in office hours, he could pull up their clicker record, say, okay, what did you answer on this particular question? Oh, you answered a 16, you answered 1,6. Okay, let's make sure you understand the electronic activation of the reaction partners. So it's really refined data in terms of a complex process. Here's an even more complex one, right? So here, use the numbers and locators as letters, identify the following compound. Just a personal note, my daughter was taking organic chemistry in college at the time, so I sent her this question just as a double check. I don't know any organic chemistry, and she came back, and essentially the way the clicker question would be answered would be 3H2Ga, because once again, if you're organic chemist and you're working through this, you would probably by this time have reached the conclusion that it's a 3-ethyl-2-methylpentane, right? So many of us have other types of processes or concepts within our disciplines where there's a multi-step process. And so this was a great example of, okay, first you do this with this particular thing, then you do that with that particular thing, and putting all of those pieces together. Right? This could be a good solid 5 minutes spent on students working through something like this, but you get a lot of rich data in terms of our students understanding the structural pieces and then also the reactant pieces in this particular case in organic chemistry. A couple of other question types love to share with you. So analysis, another kind of deeper or higher level Bloom's critical thinking type skill, right? So once again, in my faculty workshops, I like to change it up and bring things from many different domains. So here is Mark Clattenburg, a pretty famous English soccer referee, giving a red card to Robin van Persie, who used to play for Manchester United at the time. And so there's a proper order. As a soccer referee, you know there's a proper order in which you're supposed to do stuff. So once again, using alphanumeric entry, I have people enter the response. But if you, once again, if you're a soccer aficionado, you will notice that there's something in there that's a little bit wrong, because if you get a red card in soccer, your team plays short and there's no substitutes. So this is a kind of a question where sort of surface knowledge versus deeper knowledge, right? The tendency might be, if you don't quite know the discipline, to actually go ahead and use all 4 choices, but by leaving C out, you're actually demonstrating much deeper knowledge of the material. And so this is the kind of thing we want to give students practice with in our classrooms, so when they encounter a question like that on the exam, it's not a trick question anymore, it's really probing depth versus shallow knowledge. I just have a couple minutes left in my presentation. So I want to talk a little bit about why I think clickers are really fantastic for allowing us to show off great lecturing skills, right? So even in the active learning classroom, of course, you want to show off your skills as a teacher, and this is what I call agile lecturing. And so we'll go through a couple of these thought exercises. Suppose you got this scenario, right? So you have, obviously there's a lot of students in this class, well, probably 150 plus, and the correct answer is A, but this is the data distribution. Right? So this is now you have to make a decision as a faculty member. It's a bimodal distribution. So if you don't tell the students the answer, peer instruction is likely to work pretty nicely, because 2 students sitting next to each other may either be in the A or C category, and they could, talk to each other and try to figure out what's the correct response. So that's one scenario. Here's another scenario. Right, the correct answer is B. 128 students got B. So you might be tempted. Okay, do I go on? Most of them seem to got it, but there's 22, which is not an insignificant number, who answered C. So once again, you as a faculty member have to make a decision. What do I do with those 22 students? Here's one, which is usually a good one, an easy one for people. You know, correct answer is D, and there's 90 people answered A, right? So there is a small minority who answered D, but once again, this gives you an opportunity to think, okay, most likely I need to reteach this topic, revisit it, rephrase the question, whatever the case might be. Here's a good one. I've actually had this happen to me, and I was sharing with Rhonda earlier that when this has happened, I've actually had an entire class burst out laughing, because when I shared this data with the student, they realized that everybody's confused in the class. And so if you, as an instructor, are comfortable with that, everybody laughing at you, and you realizing that, okay, here's a major point of confusion, the great thing is that you know right then and there in the lecture what this point of confusion is, and that you can address it. And then hopefully, after you've done sort of some peer instruction and you've done some direct instruction yourself, this distribution changes. And then finally, there's one other last one that I wanted to share, which is this is more classroom management. There's always some smart Alex in your class. And so here's a question with 4 answer choices, and yet somebody answered E. There's 3 people who answered E. And it's always interesting to think about, okay, what would I do in that case? How do I deal with those 3 students? What might have caused that to happen, right? Somebody could have just clicked the wrong button on the remote. That always happens as well. But some food for thought, hopefully, for you. There are lots of great resources. Here's some from Colorado, from Vandy, and from the Carl Wyman Science Initiative. And these are pretty easily available on the web. I'd encourage you to look them up. So I've been zipping through all this material. So let me now pause for 30 seconds as we get ready for our Q&A. And I'd like you to revisit your webinar goal. Did you accomplish your goals? And then it's a good time maybe to have a quiet time to phrase a question that you might have.
We do have some questions, or if you'd like, I can give people a few seconds, but otherwise I'm happy to pose a couple questions that have come in.
Let's just wait 15 seconds and then let's go with the questions.
You bet.
All right, go ahead, Rhonda.
So one of the questions, it was actually posed a little bit earlier. I think it was back when you were talking about some of the research, like the Eric Mazur slide, but it was referring to how often were clickers used, or clicker questions used in each lecture. Okay,
so that's a really great question, and it's actually been there's a couple of nice articles. Joan Handelsman, her group did a nice article actually in Science, I believe, talking about what's the design of the lecture look like. And so going back to connecting with the attention span data, in a 50-minute lecture, right, it's talking about doing mini lectures of about 10 or 12 minutes, and then doing a 2 to 3 minute pause for a clicker question is one of the recommended modalities. So then you might end up with 4 or 5 clicker questions in a 50-minute class period.
Okay, and there is a second question. I think this is a really good one. Is your definition of active learning primarily focused on clickers?
No, it isn't. In this particular case, the reason for really kind of focusing on clickers is that it's a sort of low adoption threshold technology, and it's a technology that, and it's a mechanism, I guess not technology, but it's a mechanism for getting both the faculty and the students some information about what's going on regards learning in the classroom. And that still, unfortunately, today, many people are forced to teach in spaces where, in fact, the lecture is the only sort of feasible way of doing interaction. And so without increasing a big burden in terms of paperwork and grading, I think clickers provide us both an efficient and effective way of introducing active learning. It's a small, what I'll call it, a small perturbation on sort of typical traditional lecturing. So in my work in faculty development, I found it's a step that you can convince people to take, and then maybe if they, as they get a taste for active learning, then they can go into sort of more extreme active learning cases, let's say where the learning spaces themselves are designed very differently than a lecture hall.
Great, I think that's really helpful. We have another question about how do you handle students who have accommodations and require extra time to answer questions?
So one of the nice things I like about the clickers in terms of accommodations, the fact that they have clickers that are accessible to or usable by people who are visually impaired. So that's sort of a nice aspect to it. In terms of accommodations for additional time, it's not something that I have come up with in terms of actual formative use in the classroom. Usually those have been applied to settings like exams. So I don't directly have an experience with that particular aspect.
Okay, we have another question, and I'm hoping I'm getting to the gist of this. It's someone who would like to know what others do with some of the response scenarios you gave. Like, for example, if 90% of the class gets a question correct, you know, do you just move on or even go over the question, or, you know, just certain maybe guidelines with any additional scenarios? And I'm sorry if I'm not articulating that question properly. If you have any clarifying comments, you know, feel free to put that in too. I just want to make sure. Yeah.
So I will say one thing that I've seen is that very often faculty, so here's one of the situations, right? 90% of people got it right, or over here where 90% of the people got it wrong, right? In both of those situations, faculty very often are in the immediate reaction for many people is to look inward and either, you know, congratulate themselves or blame themselves, either way. And so what I really get people to start thinking about is, don't forget, you have these students as resources, right? So these are college students, they're intelligent human beings. And as a first step, always really think about, okay, you know, is there some benefit in terms of students taking their first shot at kind of dealing with this particular issue? And that'll vary depending on your student population. But what would, you know, don't look inward, look outward, use the students as a resource, and then think about, based on that additional piece of data, what might be the step that you take.
Okay, we have another question. Do you use the clicker system for proctoring quizzes? And if so, what is the recommended number of questions to use on a clicker quiz?
Okay, so yes, I have done clickers with quizzes. And so, you know, quizzes typically should be a 10 to 15 minute exercise. 5 questions or so are reasonable to put on a quiz. When I do clickers with quizzes, however, I like the self-polling feature, which I think we've just finally gotten back into iClicker. But when I first started using clickers, that system had the self-polling, because any type of a graded assessment like that, which is a slightly higher stakes assessment, I really don't want to necessarily dictate the pace at which we're going through. So I would give students, okay, here's this 15-minute window, and use self-polling type features and work through and respond to the questions in whatever order you want. That then takes out some of the test anxiety, but it also allows me to efficiently collect the data.
Okay, there's another question regarding your last slide and the student who answered an option that was not part of the selection options.
Right.
I thought the software lets you determine the number of answers learners can select.
I mean, I would have to check that in terms of just the latest, where the software is at the latest level. But you know, if we're talking generally in systems, I don't think on the multiple choice, it just is a multiple choice, and multiple choice, of course, can take up through 5. So that may just be, you know, a feature between some of the latest versions of the software. So.
Yeah. Are clickers used in the online environment? I know you can pull in big blue button. I'm not sure what that is. Any further ideas?
Sure. So, whoever, thank you for asking that question, because I was just speaking with Rhonda about that a few days ago. I would really love to see ways in which we can do, you know, really integrated clickers for online teaching, both synchronous as well as asynchronous. So Big Blue Button is one of the video conferencing software, so we use that at South Alabama. I guess the other thing that you can do, if you have, in fact, a synchronous live session, you could run a web-based polling software in parallel with that session. And then simply, you know, if you have multiple windows, share that window with the students when you're in Big Blue Button or whatever web conferencing system you happen to be in. And so then do this whole aspect of display. So that's for synchronous live sessions. If you're doing an online class and it's asynchronous, then of course it becomes trickier. So that's still a nice problem that we have out there to solve. But I'm very interested in really supporting polling, different kinds of polling soft systems within online classes as well.
Yes, that is a question that we get pretty frequently about use in distance ed or online courses. And we have someone who is doing it, and he's creating a document for us just with tips and tricks on, you know, some of his best practices. It's not a perfect solution, and there's definitely some downsides and obviously things that we need to work on. But I did want to let you know about that. And this system kind of lets us know who is asking which question, and I'm happy to send that once we get that in a publishable format. It's being formatted right now, but I'm happy to share that with you when we have it looking nice.
Okay, so, share it with me as well, please, Rhonda. Yeah, that'd be great.
Yes, yeah, happy to do that. Okay. Do you think clicker technology can be used in cooperative learning activities or group work?
So I think they can, right? So I think right now at our university, there's a big team-based learning effort. And so team-based learning is a highly structured type of cooperative learning activity. And there are people using self-polling and other types of features within Clicker software to have people respond, essentially do quizzing. And you know, you can always have people, you can just use one clicker in a particular group to be the clicker that's voting for the group on particular issues. I will tell you, I've actually used clickers in a pretty high stakes environment with a bunch of NASA people, and we were on a strategic planning committee where we had to make decisions. We had one day to work on some strategic planning items, and I had people vote for their top 3 items that they wanted to work on for the rest of the day. And what happened was, even with these big NASA scientist egos in the room, because we just did it in a very transparent fashion and just kind of voted on these using anonymous technology, we had basically no issues or no questions about what were the top issues that we should talk about. And so that was a place where we were doing another type of activity, but polling technology really helped us streamline our process for doing it.
Okay, great. I think that wraps up our questions here. You know, we can stay on for another minute or two, although we are just about at time. But I in the meantime, I do want to thank all of you again for your time and some of the great questions that we've had. And I hope that you all have a great holiday season and great wrap up to your semesters. And I want to thank Dr. Chowdhury for a wonderful presentation. Thank you so much.
All right, thank you. Thank you for having me, and thanks to all of you who joined in for the webinar.
All right, great. Thanks, everybody. Bye-bye.